Hi, everyone. Welcome to Wednesday. Well, for me, Tuesday, but for you, Wednesday. And so we are on, we're just finishing up this lesson, and it is on page M2, 212. So it's just 212 in your, the packet that is titled, what was it titled again? 1x, one or more x's to 1y. So we're just continuing that. And so hopefully you did not pick up your packet on Monday. You're going to do it today, 8:30 to 3. All right, so here we go. So we're on 212 right now, and we're determining whether a relation is a function or not. So remember we talked about that yesterday, and if you were not here yesterday, then go take a look at that video. All right, and so here we have a mapping here. We're looking, okay, so for this 10, does it only go to one answer? Yep, it goes to 1,000. For 11, it goes to one answer, 1,000. 12, 3,000, 13, 2,000. So each of these inputs leads to only one output, which means, yes, this is definitely a function. So function, because I'm just going to be easy. Each output or each input gives only one output. Okay, that's how we do that. And then for this number 2 right here, okay, 10 leads to 1, 11 leads to one answer, 12, now 12 is a problem, right? Because it leads to 2. So if it does that fork thing, like this, if it splits into 2, it leads to 2 different answers. We can't have that. It should always be predictable. The input should always lead to one output. So that's what that should be. So this one is definitely not a function. We say not, I can write not a function. Apparently I cannot. All right, so this is not a function because 12 has 2 different outputs. So we're just trying to be specific here, all right? And so we're taking a look at this. Now it's not mapping, but we do have this input and output. And what I like to look at here first is I look at the inputs. Okay, are they all different? And if we're like, okay, they're all different and they all lead to a number, right? So this is fine. This is definitely a function. Function, because I like to use BEC. I started abbreviating when I went to college because the professors just talk so fast and you're just like, rrr. So like quick write. So I just did BEC. I know some people do B/C, do whatever you wish, okay? But I do BEC because each input has only one output, okay? And so, yeah, a little bit word, different word, but same thing. Okay, so then we're going to take a look at table B, and we're like, okay, so I do have some repeats here, and repeats are fine as long as it leads to the same output, right? So if I'm looking right here, so I have 2 2s right here. Oh, but here's the problem. One time I put in a 2 and I get a -4. Another time I put in a 2, I get a +4. That's different, so that's not going to work out. So even with that, I don't even have to look any further, right? But just in case, so I hear, look, if you look right here, oh, we put in a 1 one time and you get a -1, and 1 another time you get a +1, right? So there's 2 instances of that. So even if we had the 1, it would not be a function. So we would say not a function because 1 and 2 have 2 different outputs, or both have, I should say. All right. And so sequences, just so that you know, if we were to number these, this is so the sequence, the term number, which is like 1, 2, 3, 4, that's going to be our X, and then our Y is going to be our sequence, right? So if you look right here, that's going to be 7, 10, 13, 16, 19. We do not repeat. We just keep on adding 3 every single time, right? So this is a function. Because again, each input has only one output. because that. And then for sequence, this one, if this is the first term, second term, third term, fourth term, and if you notice, each input has one output, right? So that also is going to be, what is it called? A function. Right, so this is going to be function as well. So function because for each input has only one output repeated. All right, so we're looking at set A. And if you notice right here, we're looking at the inputs right here. Let me highlight them for you. So look at we have two. Well, we have two. Right, so all these inputs are we have one input. But how many outputs do we have? We have 3, 4, 5, 6, and 7. Ooh, this is definitely not good. So this is definitely not a function. Because 2 has more than one output. Okay, and let's take a look at this one. Let's look at our outputs, and this is 2, 3, 4, 5, and 6. Okay, and if you notice right there, they're all different inputs, which means that it doesn't matter what the output is, even though they're all the same, right? One input leads to one output. Therefore, it is a function. So we're going to call this function because every input has only one output. What that is. All right, input, scenario A. The morning announcements are read over the intercom during the intercom system during homeroom period. We haven't gotten that in a while, right? And the output is all students report to homeroom at the start of the school day to listen to the announcements. Yeah, so one input, many outputs, definitely not a function, right? Not a function. And then this one right here, each student goes through the cafeteria line and each student selects a lunch option menu from the menu. Lunch option from the menu, right? One student, one lunch. There we go. So it's not one student, two different kinds of lunches, right? So that is definitely a function, assuming that nobody is doing that. All right, so now function as graphs. And again, I would, if you've just been working right alongside with me, that's fine. But it would be better if you do it first and then watch the video, either way. All right, so a scatter plot, and you should be familiar with scatter plots. You'd usually do them in science class. And if you're not yet aware of that, or if you've never done that before, then hopefully in science class in high school, you'll do that. All right, so a scatter plot is a graph of a collection of ordered pairs, so points, right, that allows an exploration of the relationship between the points. Usually we talk about correlation with scatter plots, right? Does it have a positive correlation, a negative correlation? Does it have no correlation, right? So these are two examples of that. And it says, determine if each plot represents, or each scatter plot represents a function, and explain your reasoning. So if we're like, okay, one input, one output. Okay, so at 1, we only have one instance of 1 here. And at 2, we only have one instance there. 3, yep, only 3 gives me a 1 every single time, right? And a 4 gives me a 1, like a 4, so it doesn't, we don't have, this as a function. Okay, one input leads to one output. Okay, now if we look at this guy, so if we put in a 1 for x, we get out a 1 for y. Okay, so a 2 for x, we got a 3 for y. Okay, we have nothing for 3. Let's look at 4. Like if I put in a 4, you see I get a 1 sometimes and I get a 4 sometimes. This is a problem. Okay, we cannot have that. That means we have 2 x's here, or 1 x here. Once it's both times it's a 4, and then we get 2 different outputs, right? This is a no-go, right? And this is alluding to, we would call this not a function. And if you notice right here that this is, you notice the points, they're like vertically aligned, right? We can't have that. So that's why we call this the vertical line test. So literally, I usually take my finger, because my finger is used as a vertical line, right? And I just go across the graph, right? does it hit my finger at the same time and more than one place, right? So if this was my finger right here, right, it would hit these 2 points at the same time. That is not a good thing. So that's how we know it's not a function. We call this the vertical line test or the finger test. I'm just kidding. Just the vertical line test, right? So, and you'll see this quite often, or like to check if it's a function or not a function. And this is only, you can only do this if it's a graph. Obviously, if it's a, if it looks like this, you cannot do the vertical line. That doesn't make any sense. You can't do this. Only for graphs, okay? So we're going to take a look at this worked example here. And it's like, okay, so you're going to do the vertical line test, right? So we're figuring out all the lines, all the vertical lines that could possibly happen. So if you try this one right here, we draw a straight line through here. Like, does it cross the line more than once? We're like, nope, just right there. You just keep on going. Oh, here's another. Does it cross the line more than once? Nope, that's good. And then we finally get to this one, we're like, oh, yeah, it crosses the line more than once, right? At 2 different points, right? So that's why even at one point, if it does that, whole thing's not a function, right? And that's why this is not a function, okay? And let's try some more. So if you look at A, right? We're doing the vertical line test. So actually, so if you're like, oh, we draw the line here, that's only crossed at 1 point. Doesn't matter, we gotta keep on going. So keep, you know, if you're moving your finger across, right? Imagine there's an animation that does that. So if we go right here, we're like, oh, it crosses at 2 points. You could just stop right now, okay? And honestly, you probably didn't even need your finger, right? Because you can see, like, yeah, it crosses more than once at the same time at that vertical line, right? So yeah, this is definitely not a function. So now it's the same kind of shape, but it's, instead of this way, it's this way, right? So does it cross more than once at any given time? You know, like if you're like just drawing these vertical lines here, like, nope, it just crosses only at one time, right? At any given time, right? So, so this one definitely is a function. Okay. All right. So now we're going to take those, remember these functions or these graphs, shouldn't say functions. Remember these graphs? We did this from the first the lesson number 2, right, in the packet. Now we're going to sort them into function, not a function, okay? So this is our last way of determining that. So if we take a look at this, we're like, okay, vertical line test, this one passes the vertical line test. So yep, A is in here, B, yep, B is in there. So basically, if I were to take a vertical line, let's see if I draw a vertical line. Okay, that's kind of vertical line-ish, right? And I take this point and I just go across. Does it cross the line at any time, twice any time? No, it doesn't. What about for B? No, 1 time. What about for C? Only once. And what about, oh, I should probably do it for here too. I should probably write that down. So C is also function. And then we're gonna go to, what about D? Oh, all day long. Like, do you see this? How it has 2 points right there? So D is definitely not a function. So we can't do that. And then we're going to do the same thing for E. So E, does it cross at twice at any given point? Nope. So E is a function. Oh, but what about F? Right here, right? So that's going to be not a function. So E is a function. F is not a function. Which is weird because it starts with F. Oh, well. All right, now we're going to go to, oh, we're going to G. Is G a function? Yep. What about H? At any given point. Remember, you can't tilt it, right? Because it's the vertical line test, right? So, yep, G and H are both functions, but when we get to I is definitely not a function. So we go G and H are functions, and then I is not a function. Okay, we have 3 more to go. So let's take my vertical line, or you can use a ruler, I suppose. And if you're like, okay, oh, right there, does not pass the vertical line test. So we're going to be like, okay, J is definitely not a function. J, not a function. It crosses right there. Bad days, right? And then we're going to go with the next ones. So here's K. Yep, only crosses it once at any given point. And what about L? Yep, L2. So these all are, both of them are functions. So K and L. All right. And if you notice these functions, these are all functions that you'll be learning later on. Like C, you'll probably learning this in Algebra 1, and you'll get back into it in Algebra 2. D, circles, Algebra 2, and as well as pre-cal. These kinds of parabolas, that's going to be in pre-cal. This one is like the sine wave or the cosine wave. That's going to be in pre-cal. Piecewise, maybe this class, the Algebra 1 class, also Algebra 2 class. We'll see, right? And all these lines, we're going to be doing lines for days, okay? So lines, get ready for lines. All right, and then we got functions as equations. Let's see here. So determine whether each function is an equation. Nope, each equation is a function. List 3 ordered pairs that are solutions to each, if you're ready for this. So literally you can just choose any x's. It doesn't really matter. But so if we put in an x, will we get one result? Yeah, if we put in x, we'll get one result. So let's pick an x. Pick a number, any number. Let's see if we can read your mind. You pick the number 3. All right. You know, even if you didn't, this is a function, because every time you put in an x, you're going to get only one y, right? And if you don't, you did it wrong. Okay, so we're going to do the work over here in A. So 1A, we're going to just pick 3 numbers right here. So we're going to go y is equal to 5 times, and I picked 3, right? So 5 times 3 plus 3. So y is equal to, remember the order of operations, right? We go 5 times 3, which is 15, plus 3. So y is equal to 18. Okay, so our ordered pair would be 3, 18. All right, and then because it asks us to list 3 ordered pairs, so we're just going to do a couple more, right? And then so just pick another number. I would pick 1 or 0, right? So those are easy numbers, right? So 5 times 1 plus 3. Where am I getting these numbers? I'm just picking them because it just says list 3, right? So we're just picking any of these, right? So any x's. You could literally pick, if you want to pick a negative 100, you can. It's a big number, but you can. So y is equal to 5 times 1, which is 5, plus 3, and this is going to be 8. Okay, do you see how I'm writing my workout like this? On a test, I would imagine that you would write your workout like this, so I can see what you're thinking. So we're going to write the ordered pair 1, 8. All right, and then the last one is going to be, see if I could think of what you're thinking. You're thinking of the number. Shall we do a negative number? Let's do a negative number. Negative 5. Were you thinking of negative 5? If not, that's okay. You could just do whatever your number is, right? And so y is equal to 5 times negative 5, which is going to be negative 25, plus 3. So y is equal to negative 22. So our ordered pair is going to be, let's see here, negative 5, negative 22. Okay. And so do you see how we would only get one answer? Like there's literally no other way to get another answer. And so you're probably like, well, how could you get another answer? So if we take a look at, well, and we're not going to do all of these. I'm going to have you take a look at letter E, right? So if you take a look at E, right? So if you notice right here, we don't have an X. Literally, there's no X here, right? So what does that mean? You can literally pick any number for X, because what is Y going to be? Y is going to be 4. Literally, Y does not care what X is. Okay, and so if I pick a number like 2, what is Y going to be? 4. If I pick a number like negative 10, what is Y going to be? 4. If I pick a number like 1 million, I probably shouldn't put a comma there. So we'll do 1 million, that's 6 zeros. What is Y going to be? 4, right? And so literally if we were to graph this, if on the X, like here is the X and Y axis, it's literally going to be here. There's Y is equal to 4. Straight line like that. It literally does not care what X is. Y will always be 4. Always 4. Okay, so that's what that is. And then what about, so is that a function? Oh yeah. For every x, there's only one y. That one y is 4, but there's only one y, okay? So what about this one? So we should write down this as a function. So if you look at f, right? So it says x equal to 2. Well, what's y? They don't care what y is. Y is gonna, x is gonna be 2, no matter what, right? So we're gonna say, well, if x is 2, what is y? Literally, it does not matter because there's no definition of y there. So I'm gonna say y is 5. Well, if x is 2, what could y be something else? Yeah, sure, because it doesn't matter. Because as long as x is 2, this is cool. So this is gonna be 8. If x is 2, it could be negative 100. As long as x is 2, it does not matter what y is because literally it doesn't care because there's no mention or reference to y here, right? So what in the world does that mean on a graph, right? If you look at the graph like this, right? So here's your x and here's your y. So literally, here's x equals to 2, and there's your line at x equals to 2. So this is literally what x equals to 2 is. So remember the vertical line test? Does it pass the vertical line test? No, not at all, right? So remember, it's a straight line up and down. So literally, it touches the vertical line at all points, right? So so this is definitely not a function. So remember, because if you notice right here, we have one x, one input, and we have how many outputs? A lot, a million, an infinity, right? So that's what that is. All right. So here we're saying the equation of y squared equals x represents a function. And they're saying that if you see this thumbs down, that means, nope, this is wrong. Well, then why is this wrong? So let's take a look here. We're looking at x. X is equal to 4, and then we've got y is equal to 3. X is equal to 9, and y is equal to 3. X is equal to 25, y is equal to 5. Why is that right? It seems to be fine. So why are they saying that it's wrong? So remember that the equation is y squared is equal to x, right? So let's pick another number for x. Well, okay, we should prove that it should not be true. So let's try 4, right? So 4, if we put in 4 for x, we're gonna have to prove it. We have to find a different number other than 2 to make it work, right? So remember, this is y squared, right? So we're going, what number squared will give me a 4? Here they said 2 squared. So we already know that 2 squared is taken up. So is there another number when we square it that equals a 4? What could that be? And if I think about it, I'm like, wait, what about a -2, right? Because remember, oh, that's a negative. So remember, the square means that it's going to be -2 times -2. Does that equal 4? Like, yeah. So that's why. So this is negative. So remember, 1 input, 2 different outputs, right? So that is not possible. This is not a function. That's why it's not a function. Okay, so we had to dig a little bit deeper. Okay, and that would be true if you notice D right here. It's also not a function. You'll see this one. This is actually the equation of a circle with a radius of 1. And if you put that in your calculator, your graphing calculator won't work because they don't know how to compute that. Literally, you know why? Because it's not a function. Calculators don't work with functions very well. They don't know what to do with them. It is non-operable. And this one right here for C, this is a function, and D or B is a function as well. It's just going to be D and F, the same. If you wanted to try that out. Okay, so, and then you're just going to do your homework here. And if you take a look, thanks for being with me here on an asynchronous Wednesday. And, ooh, did I forget to tell you? Okay, so this was your, what is it called? Your learning targets for today. So, so let's see if you know. You're going to be able to describe a functional relationship in terms of a rule. Okay, we already talked about that before. Of a rule, you know, 1 input for 1 output kind of thing, right? And I will learn to determine whether a relation represented as mapping a set of ordered pairs, table, sequence, graph, or context is a function. So you should know whether something is a function or not a function now, right? If you don't know, rewatch the video. All right. And so again, here's the PDF of our lesson today. And notice, right, oh, and under here, this is going to be the video right here. And right here, this is going to be your homework right now. So it's going to be page 219, problem number 5 through 10, and then 1D. So you weren't supposed to do 1D yesterday because we technically didn't go over that. So 1D and number 4. So if you take a look at that, so this, let me see. So this is going to be your homework right here. You're doing this right now. So 5 through 10, right? You don't have to copy, if you want to copy down the whole problem, that might be helpful for you for, you know, when you're taking a test and stuff like that, right? As a reference to these definitions, right? And then you're going to do this part right here, the D, 1D. So now that we know how to do a scatter plot, right? Just plot the points. Or maybe you already knew how to do that, right? And then, but we've talked about the scatter plot, and also number 4. So right here it says, using the vertical line test, determine if each graph represents a function. Explain why. Did it pass the vertical line test? Did it not? Oh, wait, maybe I gave out too much. And then just make sure you're checking your answer. So if you go right over here, if you go to just hit next, or you could just click on this right here, it'll go to the answer. So make sure you're checking your, let's go here. So here's going to be today's work. I have a joke on there. And then so check your work today, and then you're going to write your reflection for today. If you have any questions, please let me know. It's all on here. Then hit submit. Don't forget to hit submit, because it's not going to come to me if you don't hit submit. All right, and then don't forget your math yet, okay? Because you remember you should be finishing up 2 workspaces by Friday. Okie dokie. That's not including the getting started. So make sure you do that. All right. I'll see you later. Bye.